In this particular talk, we're going to have a look at constructors within C++. So it's following on from our introduction to classes. In particular, we'll look at the different types of constructors. We'll focus mostly on the copy constructors and also the move constructor. And in the third part, we'll round off our coverage of constructors, and we'll also go on then to look at destructors. So constructors, hopefully you'll remember from the introduction that C++, it gave us flexibility in terms of when we're creating an instance of a class. We can choose to declare it on the stack as a value type. We could also choose to create it on the heap to allocate a chunk of memory and then to access it through a pointer or a reference to that. And because we have this flexibility, it meant that whenever we are assigning or copying one class to another, doing, for example, A is equal to B, it was a little bit more, we had to be a little bit more careful that we were copying the contents of one object into the contents, or defining the contents of a second one. It wasn't just simply copying references. And that meant then that we had to have a number of special types of constructor, and that's what we want to have a look at. Within C++, you can actually define 4 different types of constructor. You can see them listed here. We've got a default, parameterized, and these are the two ones that are common within, say, Java and C# as well. We've got a move constructor and a copy constructor, and they're the ones that are a little bit more unique and specific, or certainly differing than Java and C#. And they're the ones that we want to focus in. But we'll do default, we'll do parameterized just by way of completeness. So default, first of all, it's a constructor that can only be called without an argument. You're not allowed to pass in any values. Also known as the no argument constructor. It's the one where if you say, give me an instance of this class, but you don't say anything else, it gets to be created by default. Obviously, you can only have one default constructor. If you tried to declare 2 of them, you would have no way of working out which is the right one to call because you have no arguments to differentiate between them. C++, see this over towards the bottom, there's actually slightly different syntax depending on where it is you are creating the instance of the class, if it is on the stack or on the heap. So in line 1, we do class name and give it some particular name. Now, if this were Java, all we would have done here is declare a reference to a class and we wouldn't have assigned it to anything. In C++, we actually are creating an instance of this class. It'll exist, it'll be created on the stack, and the no argument constructor will be called to actually construct that object on the stack. If we're creating it on the heap, we're allocating there using the new keyword. Syntax line 2, we have to use our brackets at the end and signifying there that we're not passing in any parameters to it. Next one up then is the parameterized constructor. Now, I'll read out the bit at the top. It has at least one parameter without a default value. So parameterized constructor, it accepts parameters. You can pass things into it. What's this notion about default values? Again, it's a reasonably nice thing about C++. You can see an example underneath it where we have a rational number class, or the start of it, where we've got a couple of private variables, numerator and denominator, and we've got a public constructor, and this is a parameterized constructor. And you can see there that when we're passing it in, we pass in num and dem, but for the denominator, the dem value, we are saying equal to 1. Now that is a default value that if I call rational number, and I only pass in a single numerical value, let's say 7, then that is assumed to be the num value, the numerator, that'll take on that value. Because I haven't specified a second parameter, then the default value kicks in, and a default value of 1 would be considered. It can be nice. It can save you from creating lots of sort of very similar forms of constructor. Another nice, just an aside, a nice feature about C++, you see this in lines 10 and 11. This is about how we actually assign parameters passed in as arguments. Within, well, take a step back. When we create an instance of an object, so we are allocating some memory, let's say for example on the heap, What happens after that is generally that memory is cleared. You initialize it all to 0. You zero the memory. That's generally done. And then you call the whatever it is the user has defined within their constructor to populate it with default values or do whatever else is needed. There's a certain inefficiency within that. Let's say that if I did call a rational number passing in a value of 7, what I would end up doing is allocating, let's say 4 bytes on my heap for storing the M numerator. I would then zero that memory, set it to 0. And then in line, or whenever I get down to it, I would then assign it, copy across the value that was passed in as an argument. So the work that I did to 0 to initialize that memory is wasted work. It was unnecessary work because I'm going to overwrite it immediately. And C++ gives you a feature, you can see in this the syntax in line 10, line 11, to say that for the default, for the starting value, the value you initialize it to, what it should be. So in line 10, we will not try to zero the memory for numerator. We will set it equal to whatever num is. So it is optimally efficient in that particular regard. Okay, so that's the default. That's the standard parameterized ones. Let's have a look then at, we'll do copy first, move thereafter. A couple of different types or flavors of copy constructor. We have our basic copy constructor and also our copy assignment constructor. So we want to look at both of those. There's not a particularly major difference between them, I suppose, in terms of the copy constructor and the copy assignment constructor is very much the same difference you have between a copy and a paste. If we're using the copy constructor, what this means is that we are actually creating a new object. It involves creating an object and then copying across into that object the values from another object. Assignment, on the other hand, for example, A is equal to B, doesn't involve the creation of anything new. It simply involves we have two objects that already exist and we're having to assign the values of one to whatever values are stored in the other. So slightly different syntax holds for both of them, though in essence we're trying to accomplish the same thing. You can see an example of how it works here the default way. So we have over on the right hand side a class called store. Public section, we're declaring a few public variables, probably not great practice. Nonetheless, at line 4, var1, var2. Line 5, we have a parameterized constructor. So here we're taking in int v1 and v2. And what we're doing in line 6 is saying that var1 should be initialized as v1 and var2 should be initialized as v2. Doesn't do much. Underneath that, we're actually going to make use of those constructors. So we've got our method called foo. Line 3, we call the parameterized constructors. So we're creating one called A with a default value of 0, 0. And then B with an initial starting value of 10, 4. At line 4, where we do an assignment, A is equal to B. Now, at line 3, both of these get to be stored on the stack. They're value types that we have created. Line 4 is an example where we actually kick in our copy constructor. We are copying all of the contents that B holds into A. So after we do that, then a.var1 is equal to 10, a.var2 would be equal to 4. The values have been copied across. So in essence, it's what's known as a member-wise assignment. You will know what variables you have declared within your class. So for store, we have var1 and var2. And when we do a copy constructor, all we want to achieve is to look at the variables within, let's say, B, and then copy those across to the corresponding variables within A. If we do that, then we have made a copy. We've made a sort of known as a shallow copy of our first object. C++ actually provides you with a built-in, a default copy assignment constructor for all of them. So A is equal to B, we will always be able to do that. Even if we don't define our own one explicitly, we get one built in. And all the default one does is that member-wise assignment. It will go to the one we're assigning values to, go through each of its different properties, go to the thing we're assigning from, and copy the value across. that works well unless, or if it works well until you end up having a pointer to something else within your class. Because this member-wise assignment, it will copy the value that the pointer has. So let's say we have an object that contains an array of data, or rather it contains a pointer to an array of data. If we were to make use of the default copy assignment constructor, we will copy just that pointer, not the actual array or the contents, just the pointer. So then after that, we will have two objects that point to the same, for example, array of data. And that probably isn't what we want to have happen, and it can be dangerous because then we have data shared between what are otherwise two separate instances. For the copy assignment, and we're going to look at how we can deal with that in a little bit, but for the copy assignment constructor, you can see the form that it takes over on the right hand side at the bottom. It looks complicated. So line 1 we have foo, a reference to foo, the name of the class foo itself, then we have this operator equals and another reference to the source. Let's break it down. This is the standard format. So if we want it to perform, for example, a deep a copy assignment, so we're going to not only copy the pointers, but we're going to say, let me create a new array of data and copy the content across and give you your own pointer to that, so that if you like to cleanly copy. We need to provide our own implementation of the copy assignment constructor. The default one won't cut it in that case. So what we do is that we actually will be specifying how one object gets to be assigned to another one. And we do that in C++ by overloading the assignment operator. We can change how assignment actually works. And the default form is given there. Now let's have a look at those bits. Well, actually we'll start over on the right hand side. So what we're passing in is const foo ampersand source. So foo ampersand is a reference. We have a reference to the object we're copying. You think about assignment. Assignment, you don't change the thing you're pointing to, you copy from it. So we have a constant reference. So it must always point to source. We're not allowed to change the thing we point to. It's a reference. It's a constant reference. We're not allowed to change the contents of the thing that we point to. So basically, source is read-only. And that makes sense. We just want to read the data. We can't do anything else. The operator equal to. We're going to look a little bit more about overloading operators in the next slide. But in essence, that is the equivalent to the variable name. So as opposed to having a string of characters describing the method name, here we're saying that this notional method name actually is the equals character, or the equal, in this case, the operator that we're assigning it to. It's part of foo, so we're saying that for the foo class, we want to define how the assignment operator works, and we're passing in then another instance of foo, which we're not going to be able to change. The return type from it then. Now, a lot of constructors, when you construct something, you don't have a return type. But here, we do have a return type for this copy assignment constructor. And the reason for that, you actually see down at the very bottom, is all about chaining. You can say that, if you integer variables, I could say the A is equal to B is equal to 4. And the value then 4 would get to be stored within A and B. So you can chain assignments together. So we want to be able to support that. So that we can do A is equal to B is equal to C, and our copy assignment constructor will hold. So the way you can support chaining is that when we are finished with the assignment process, we return a pointer to ourselves, and we're returning that then as a reference to ourselves. So that can then be passed on to somebody else, and they can make use of that by way of chaining it out. So in terms of overloading operators, you can actually overload an awful lot of stuff within C++. So I can overload not only assignment, I can overload the test for quality or inequality, less than. I can say what increment a processor actually should mean. And I can define that then for any particular class that I define. There'll be monsters here. And the general rule of thumb is that if you are going to overload assignment or quality or less than or greater than or increment, you need to be 100% certain that whenever people think about or use your class, that if we're thinking about, say, less than, what does it mean to say if one class is less than another, that everybody will have a consistent interpretation of what that means. If there's different ways you can interpret less than, then you do not want to overload this operator, because it is just asking for problems or for people to use it incorrectly. So that was copy assignment. Let's just look at the default copy constructor, and to a certain extent this is just another form of parameterized constructor. You can see an example down here in line 4. Now look at line 3. Line 3 is a parameterized constructor where we're creating an instance of store called A. We're passing in the values of 10 and 4. In line 4 we're creating another second instance of our store called B, and what we're passing in is an instance of this class. We're passing in another store, in this case A. So it is in essence a parameterized constructor. The parameter just happens to be an instance of the class that is being constructed. Again, it has the same set of issues and the same overarching goal as for copy assignment. There is a default one built in where it will do a member-wise a copy from one to the other, but that gives you a shallow copy, and if there's any pointers to shared data or to data, if you just use the default copy constructor, you get a share with that data. So you need to overload it if you want to make a deep copy and to copy all of the data. Default structure, if we want to overload the copy constructor, is one shown here. So again, it's the foo class and it's a constructor, so it's foo. We're passing in here a constant reference to our source. So again, we're constructing things. We don't want to change or manipulate or otherwise modify the thing we're copying from. So we get a read-only reference instance to it. As mentioned, there is a default constructor. Now, one of the things about the copy constructor is that, yes, we can call it explicitly, as shown in the last slide, but there's also a number of cases where it may be called on our behalf, if you like, behind the scenes. Particularly for things like casting or working out, can we convert one object into another object? So constructors can be called, if you like, without the programmer being fully aware of it. A little bit here, I don't think I need to say much about shallow and deep copy. You can see an example of it at the bottom. Generally, we don't want to, in some cases, yes, you would want to actually share the data, but generally we do want to have different instances managing their own data and not having sort of multiple links between them. Now, that's all we want to say about the copy constructor and the copy assignment constructor. It's nothing more than making sure that we appropriately copy all of the data that we associate with one object into the other. Going to go on to look at the move constructor. Now, this is something, it's nice, but it's also maybe something rather niche. But I want to look at it because it does get into the heart of how, or not the heart, but it gets into an important aspect about how some programs are, how programs are executed. So the move constructor came in with, or the semantics for it came in with C++11. That's where you sort of had it cleanly defined. It is all about transferal of ownership, particularly of data from one object to the other. And we would transfer ownership because we want to avoid duplicating and copying the data. So an example would be that if we have an object that contains a pointer to a very large array of data, I could use a move constructor to say, okay, I want to pass ownership of that array of data from this instance of the object into another instance of the object. So you're not duplicating it, you are notionally saying that you now look after it, and the first object gives up ownership or gives up access to it. It does have a number of specialist uses, and generally you do this, it's for performance reasons. It's faster to do this. And to understand the conditions, it ties into looking at L values and R values and understanding the distinction between them. Sometimes, I mean, if you look up L value and R value, you might somewhat incorrectly see them described as a left value and a right value. That's not really the case. L value is anything that is directly accessible by the programmer. And R value is a variable. Now, it could be an integer, it could be an instance of a class, but it's something that is not directly accessible by the programmer. Now, if you let's give me an example. So let's say that I've got an integer a, and I say a is equal to 3 plus 4. Or I say a is equal to this method. Call this method, it'll return you an int, and then add on to it. Call this other method, it'll return you an int. But basically a couple of ints that need to be added together, and then they're assigned to a. Now, a is an L value because I can access it as the programmer. I can say a, access a, print it out, add something onto it. So anything I can access, L value. Think about the other side, 3 plus 4, or two methods being called to give you an integer and you're adding them together. You're going to have to work out what is the sum, what is the addition of those two integers. That has to be stored within a variable, and that then gets to be assigned across into a. Now, the thing that they get to be added together into, it is a variable. It has to be created, it has to be set aside. If it's an object, it has to be constructed, then released or allocated and deallocated. That is an R value because as a programmer, I know that it's there, but I have no way of accessing it directly. If you like, it's all part of the calculations and manipulations that happens behind the scene. The scene to sort of calculate out what I want to do, but it's never something that I directly can say that variable. I can assign it to something that I can then access, but I can't access it directly. So things that are returned from methods, they are an example of an R value that you don't get access to them directly. And move constructors, they have a lot of utility in terms of making sure that we efficiently deal with R values. We have an example of the cost that can be entailed here. So these are using here copy constructors, but it's quite an inefficient example. Or I say slightly inefficient. When we look at optimization in a few lectures time, you'll see that a good optimizing compiler would avoid this cost, but we're going to present it here as a cost that may be incurred if you don't have a great compiler. So over in the left hand side, we've got a container class, two private member variables. We've got an integer called size, and we've got a pointer then, let's assume, to an array of data of whatever size we have specified. We got here a constructor. It is a copy constructor. Okay, I left out things like the const just for reasons of conciseness. So we're constructing a container, passing in another reference to a container. And you can see here on line 9, we're saying that the size, well, we want to copy the size from the other one. We want to take it on. So we copy the size across. For the data, now, we don't want to have a shared piece of data. If I want to copy the container, I want to copy the container cleanly. So on line 10, what I'm doing here is saying that the data for this container, it should point to its own array of whatever size the source has. So we have two arrays, so we're not overlapping on them. And line 11 and line 12, if you like, into the user-defined components of the constructor, what we're saying here is go to the source and copy all of the source data into this container's store for the data as well. And that copy constructor will cleanly copy you, will give you a new container containing equivalent contents to that within the other one. So that's good, that's what we want. Over on the right hand side then, let's have a couple of uses of this container. Let's assume line 1, we've got a method called container, get container, which will give us back out a container instance. And line 3, we're calling a method foo, and here we're passing in a reference to a container called input. Now input is a L value because I can refer to it by name. It's called input. I can access it. Input whatever I want, input.size. So in line 5, I'm calling the copy constructor. I'm creating a new container called con1. and I'm constructing it using the contents of input. And I will call the constructor I have over there on the left hand side, unproblematically get a nice clean copy of it. Brilliant, that's great. Look at line 6. This is where it gets potentially inefficient. So I'm saying here, I'm creating a new container called con2. What am I passing in? I'm going to pass in another instance of a container. And that instance is the return from get container. So I'm going to call the method get container. It's going to do something and it will give me back a container. Now, the container that I get back is an R value. I can't access it. I don't know what it's called. I know it's returned. I know it's going to be assigned, but it's not something that I, as the programmer, can get my hands directly on. So we call get container. It returns this container object. It then gets to be passed into the method. We then duplicate all of the data and all of the array, and that temporary value then gets to be thrown away, gets to be released. So this is a bit of a waste. We called a method, it constructed it, allocated an array of data. We then called our copy constructor here. We rigorously went through and made a nice copy of it, but then we threw away the contents of that temporary variable. We don't need it anymore. It would have been nicer if whenever we got the data back, we didn't have to make a complete copy of that array. Rather, we had some way of saying to this temporary R value, you know what, I'm going to take your data, I'm going to transfer ownership of it from you to me. And that's where the move constructor comes in. It's intended to enable you to, in a lot of cases, quickly sort of nix the wrong word, but to go through an R value, a temporary thing is going to be thrown away, and to quickly transfer out or to copy out or take ownership of the data within it. And then that R value gets to be discarded and nobody really cares about that. We can see here an example of an actual move constructor. Syntax wise, we need to have a way of denoting that this is a move constructor. So lines 8, that's the copy constructor. Line 15 is the move constructor. It's worthwhile having a look at them. The only difference between them is that we have container and then 2 ampersands. So if you provide 2 ampersands or sort of an extension then to your reference to something, that is interpreted then as a move constructor. You'll notice that, look at line 8, we take in a source container. Look at line 15. We also take in a source container. Both of them contain references to source containers. How does the compiler know which one to call? Because notionally, both of them have more or less exactly the same, they do have the same signature. And this gets into the notion between a copy and a move constructor. If you declare a move constructor within C++, you're basically saying to the language, here, if you want to use the move constructor, you can use it. So behind the scenes, whenever we're when the program's been executed, the language will have its own list of R values, these temporary variables that it's managing. So it can decide, okay, I'm maintaining this R value, I'm going to copy it across to something that the programmer's using, an L value. I could use the copy constructor that the programmer has defined. Oh, guess what? They've also defined a move constructor. I'm going to call the move constructor instead. So we're enriching the options that we have when compiling the program, and the compiler then gets to decide which constructor we will end up calling, and it will do it based on safety, based on performance. Let's have a look at the move constructor. So you can see it's actually simpler. What we're doing within this then is at line 16 we're saying, okay, let's go to the source and copy across its size of its data. Good. Line 17, let's go to the source. Now it is a pointer to this array of data. Guess what? I want to have that exact same pointer. So it takes the pointer to that data. That's notionally the transfer of ownership. Very important though is line 18. We are then going to the thing that we transferred it from, and we are breaking its link with it. We are severing its link with that data. So it's not linked to that data anymore. And that sort of signifies that we have cleanly taken ownership of it. The reason this is important is that, let's say container has a destructor. We've yet to look at destructors, but they decide how a class gets to be freed up and released. In this case, the destructor quite rightly would say, if you want to delete this object, you better go and delete this array of data that I'm maintaining as well. Now, If we omit at line 18, we could call our constructor on the R value, the thing has been temporarily deleted, and we could then delete the array, having just transferred ownership of it to somewhere else, and that would be a true mess. So when you are doing move constructors, you want to cleanly transfer ownership so you don't have two objects being able to link to that data. You only have one. If you look at the constructors, the move constructor, all it is there is three assignments. You're copying across the size, the data, or sorry, two copies and an assignment, a value of 0. Much faster than allocating a new chunk of data and then copying that chunk of data, if you like, integer by integer. Takeaways in this, it's not really much the way of takeaways. C++, we have a couple of different flavors of copy constructor, and in essence they're there to make sure that we correctly can specify how one object gets to be assigned to another. They're almost always essential when you have indirect data where you're pointing to other data within it, that a simple, shallow, member-wise copy will copy those pointers. Move constructor is quite a nice one because it's all about trying to give the compiler additional flexibility so it can produce code that runs faster. So it ties in nicely about one of the ways in which we can enable that.